Hello everyone. In this lesson we will talk about exponential and logarithmic functions. We continue our exploration on exponential and logarithmic functions by trying to solve a lot of problems or a lot more complicated problems with exponential and log functions. Note that our algebra is very important. Try to do one step at a time like I showed you. Whatever you do on one side of the equation, you must also do on the other side. If it becomes a bit confusing, with like a whole bunch of letters and stuff, you can do a U substitution to make it simpler. All the important things: if f of x is a function and g of x is its inverse, then f of the g of x equals x, and g of the f of x equals x. Given an equation, you may circle what you want, try to get that thing that you want to one side first, and then decide how you can isolate it. You do this in several ways, either by factoring or some other division method or so on. Ready? Now, let us look at a couple of examples of doing this. Let's look at a couple of examples of doing this. First of all, here's a question that says 3 times 15 raised to the x equals 4 raised to the x. Now, in order to do a problem like this, we must remember our laws of logarithms and the properties of logarithms, right, which I wrote here to the right side. So what you want to do, since these are raised to some power, you might want to, in order to get to the x, apply a log. An easy log to apply is the ln. So let's apply ln both sides and see what happens. So apply ln both sides to both sides. Right? Apply ln to both sides. And so we have ln of 3 times 15 raised to the x equals ln of 4 raised to the x. Now we want to think of ln of 3 times 15 to the x. Now we're going to apply a law of log, so we're going to apply law 1 to this. And so this becomes ln of 3 plus ln of 15 raised to the x equals ln of 4 raised to the x. Now we want to get the x's to one side. You might want to apply another law first. You could do this first or later on, or in the step following. But let's apply law 3 first. So we apply law 3, this becomes ln of 3 plus x ln of 15 equals x ln of 4. And now we can try to put the x's to one side. So we try to put x's to one side. You subtract x ln of 15 both sides minus x ln of 15. And so this becomes now ln of 3 is equal to x ln of 4 minus x ln of 15. Then we want to try to isolate your x. You try to isolate your x. So if you try to isolate your x, if you factor out your x, you have x times ln of 4 minus ln of 15. And all of that will be equal to ln of 3. And then finally, you're trying to get x only on one side, so we divide through by ln of 4 minus ln of 15. On the other side, ln of 4 minus ln of 15. And so our final answer will be x equals ln of 3 over ln of 4 minus ln of 15. And that is our final answer, and we're done. We just got to check, make sure that all the algebra that we did in the problem was fine, and we are good. Let's talk a little bit about the exponential and logarithmic functions, again being inverses of each other. We're just using those ideas for a while. And so this is a graph of f of x equals e to the x, it's exponential function, and g to the x equals ln of x, which is a logarithmic function. If they're inverses of each other, if we make a composition of them, then our answer will be x either way. And for your domain and range, note that the domain of e of x is negative infinity to positive infinity, which is the same as the range of its inverse ln of x, and that is negative infinity to positive infinity. The range of e of x is 0 to infinity, which is the same as the domain of its inverse ln of x, which is 0 to infinity. All right, let's look at an example. Here we're trying to find x. We're trying to find x, so at the end of the day, we want to find what this x is. We circle it there, and notice in this question, e to the 2x plus e to the x minus 6 equals 0. We want to find x. Now, it would be good to try to rewrite e to the 2x in a way that it looks like a normal quadratic. So e to the 2x is the same as e to the x times 2, and which is equal to the same as e to the x squared, right? So we're going to rewrite this expression then, or equation, e to the x squared plus e to the x minus 6 equals 0. Then do a u substitution. For e to the x, right, to make our life easier. So do a u substitution. So u equals e to the x. All right, we're still going to try to find x at the end, but we put in a u to make our life easier. So u squared plus u minus 6 equals 0. Then we can try to factor this. If it cannot be factored, a go-to method is a quadratic formula. So this is going to be u plus 3 times u minus 2 equals 0. Okay, so if we solve for u plus 3 equals 0 means that u equals negative 3, or u minus 2 equals 0 means that u equals 2. Now, let us replace this u with e to the x. So replace with e to the x. This u with e to the x. And so we have e to the x is equal to negative 3, or we can have e to the x equals 2. So let's use the inverse, which is ln of e to the x equals negative 3, but whatever we do to one side, we have to do to the other side. So this becomes ln of negative 3. Final step for this would be x equals ln of negative 3, and that would be correct answer if ln of negative 3 existed as a real number. But because we know that before this lesson, this is not a real solution. So this is not a real solution. All right? And we can extend that to say it is not a solution. Okay, for the other part, we take the ln of e to the x equals ln of 2. So x will be equal to ln of 2. And this is a real solution. A real solution. So your only answer is x equals ln of 2, and we're done, right? Now let's look at another example real quick. Let's look at another example. We ask you to solve ln of x minus 4 equals ln of x plus 6 minus ln of x. And we're going to apply a law of logs, which is the quotient law right here because of subtraction of the ln's. So right, this is ln of x minus 4 is equal to the ln of x plus 6 over x. Right? Now we can use the equivalence properties here to say that, okay, since we're taking ln to the same base, then the arguments must be equal. So x minus 4 will be equal to x plus 6 over x. And then we try to do a bit of algebra here, multiplying both sides by x. And so we have x squared minus 4x is equal to x plus 6. And then we want to bring everything to one side. And it's because it's looking like a quadratic here. So if we bring everything to one side, we end up with x squared minus 5x minus 6 equals 0. And then let's try to factor this out to see what we can have. So see what things we can factor here to get an answer for this. And so these will be two numbers that add to give minus 5 or multiply to give negative 6, and that will be x minus 6 and x plus 1 equals 0. So if we try to solve this part, x equals 6, x minus 6 equals 0, then x will be equal to 6, or x plus 1 equals 0, so x will be equal to negative 1. Right? Now let us check whether or not these make sense. So check these in the original equation. So check in the original equation. So if we check these in the original, what we have is when x equals 6, plug in x equals 6 there. So ln of 6 minus 4 equals ln of 6 plus 6 minus ln of 6, right? Notice these are all possible, right? We could work it all the way down to get ln of 2 equal to ln of 12 over 6, which is ln of 2. So these are all possible. So x equals 6 is a solution. Now, what about x equals negative 1? So check x equals negative 1. X equals negative 1, right? We check x equals negative 1, we have ln of negative 1 minus 4 equals ln of negative 1 plus 6 minus ln of negative 1. Right away, because this will become negative 5 here, ln of negative 5 is not possible, so it's not a solution. Also, the ln of negative 1 is not possible, so not a real solution. So our only solution then is x is equal to 6 is our only solution, right? And we are done right there. Okay. Thank you very much for watching. Please remember to like and subscribe, and see you next lesson.